Hello to everyone. In today's video, we are going to be looking at partial fractions. Now, this question is taken from GCE Mathematics June 2021, question 1 sub 1. The question says, express 5x divided by x plus 3 into x minus 2 into partial fractions. 3 marks. First of all, we verify if it's a proper or an improper fraction. The highest degree in the numerator is 1. Because this is a linear function, and the highest degree in the denominator is actually 2 because you expand these fractions. If we expand this function, we're going to have x squared minus 2x plus 3x minus 6. So the highest power there is 2. Therefore, we have in the numerator have 1 and in the denominator have 2. Since 1 is less than 2, therefore this is a proper fraction. So we are very free to go ahead and simply express it. Now to express it, we already saw the conditions. So since this is a linear function, we're going to use a constant a divided by x plus 3. Now since here also is a linear function, we're going to use a constant b divided by x minus 2. Now we have to take note that the denominator here is supposed to be the same as the denominator in the original fraction. So we're simply going to copy that x minus 2. Make sure that this and this are the same. Now, if we take the denominator and we bring it, we divide by x plus 3, we are going to have x minus 2. So here we have a into x minus 2. So if we do the same thing here, we're going to have b into x plus 3. Now we're going to compare this because remember, this was 5x divided by x plus 3 in x minus 2. Comparing our numerator and the denominator, since the denominator here is the same as the denominator here, the numerator should also be the same, since we are apparently dealing with the same fractions. Remember, we want to express this in another form or in a much simpler form. So it means that our 5x will simply be equal to a into x minus 2 plus b into x plus 3. We're going to call this our equation star. Now to look for the value of a and b, we have to use either substitution or we compare coefficients. So the two methods that we're going to look at in this video is, the first method is method 1. Using substitution. So using substitution, here we need to let our value of x to be another value such that when we put in our original equation star, it should cancel one of our variables, either a or b. So looking at this equation star carefully, you see that if we let our x to be let me say minus 3, this is the first condition, or this is the first substitution. If we let x to be minus 3 in equation star, we notice that minus 3 plus 3 here, this is going to give us 0, right? So it's the same thing. We're going to have 5 into minus 3 to be equal to a into minus 3 minus 2 plus b into minus 3 plus 3. What are we going to notice? This is going to give us 0. So our equation, our original equation, or our equation is going to be minus 15 to be equal to minus 5a. Now dividing all through by minus 5, this is going to cancel. This is going to, so our a is going to be 3. And this is our value of a. Okay, doing something similar for question using another substitution. Now we're going to look at another value. Now let x be equal to 2 in this case. Why 2? If I put 2 here, it's going to cancel. Therefore, I'm going to have 5 into 2 to be equal to a into 2 minus 2 plus b into 2 plus 3. Here, clearly you see that on substitute, this is going to give us 0. So we're left with 10 to be equal to 5b. Dividing all through by 5. 5 is going to cancel. Our b is going to be 2. So having our value of a and b, to get our partial fraction, we simply substitute it here. So doing that, we're going to have our a is 3. So we're going to have 3. We're going to have 3 divided by x plus 3 plus b, which is 2, divided by x minus 2. So this is our partial fraction.